So see here, next numerical is the plates of the parallel plate capacitor has an area of 90 centimeter square each and are separated by 2.5 millimeter. The capacitor is charged by connecting to a 400 volt supply. How much electrostatic energy is lost by the capacitor? And the big question is, weave this energy stored as an electrostatic field between the plates and obtain the energy per unit volume U, and hence arrive the relation between U and the magnitude of electric field E between the plates. Okay, so this question is little bit lengthy, but actually it's easy only. Okay, see here, first question they are saying the plates of the parallel plate capacitor is an area. Okay, so area value they have given, so 90 centimeter square. Okay, so next, and each are separated by a distance, so D value is so 2.5 millimeter. Okay, next the capacitor is charged by connecting to it by voltage value they have given, that is so 400 volt. Okay, next one, how much electrostatic energy is lost? So energy lost, we need to calculate energy lost. So E, so energy lost E or U is equal to question mark. And here B question is, weave this energy as the energy stored as in the electrostatic field between the plates and obtain the energy per unit volume. Energy per unit volume is, so in terms of U, in terms of energy per unit volume I need to calculate, and hence the relation between electric field E and V. Okay, so the relation between magnitude of electric field and E. Okay, so these are the required data. Okay, here 90, so centi means 10 to the power of minus 2. Okay, whole square, this should be in SI units, so that's why it will becomes 90 into 10 to the power of minus 4 meter square. Okay, so distance value it will become so 2.5 into 10 to the power of minus 3 meter. Okay, so next one, what is the A question here? So energy stored. So energy stored is given by the formula U is equal to, energy stored is given by U is equal to half C V square. So that is equal to half into, so what is C value? So C value they have not given. So that's why I need to apply the formula C is equal to A epsilon divided by D. Okay, so that is equal to, what is A value? So A value is 90 into 10 to the power of minus 4 into epsilon value is 8.854 into 10 to the power of minus 12 divided by, so D value, so distance is so 2.5 into 10 to the power of minus 3. Okay, so here if you simplified all the terms, so you will get 3.186 into 10 to the power of minus 11 farad. Okay, so this is the required capacitance value. Okay, now substitute here, so C value is so 3.18 into 10 to the power of minus 11 into V square. So V square means here 400 square. Okay, so that is equal to half into 3.118 into 10 to the power of minus 11 into 400 square means, so 4 4s are 16, right? So here 0000, here 2 8s are 16, 1 2 3 4. Okay, 4 zeros. Okay, so if you multiply 3.18 into 80,000, so you will get the answer as 2.54. 2.54 into 10 to the power of minus 6 joule. Okay, so this is U value. Okay, now first question, first part is over. Okay, next second part is we need to calculate the energy. Okay, so energy, but in terms of energy density. See, energy density is given by the formula U is equal to energy per unit volume. Okay, so energy density is given by the formula energy is equal to energy per unit volume. Okay, again volume they have not given. Okay, what is volume formula? So volume is length into breadth into height. Okay, so that is length into breadth means it can be written as area, so area into height. Okay, but here they have not given the height here, so that's why I will write D. Okay, volume is equal to A into D formula. Okay, here so U becomes U divided by, what is volume means, for volume is A into D. Okay, so what is U value here? So U value is 2.54 into 10 to the power of minus 6 divided by area value. So area is 90 into 10 to the power of minus 4 into D value is 2.5 into 10 to the power of minus 3, right? So if you simplify this, so finally you will get 0.1133 so joule per meter cube. Okay, so this is the SI unit as for the energy density. Okay, see energy per volume. Okay, volume is length into breadth and height, meter into meter into meter, it will become meter cube, and for energy it will become joule. Okay, SI unit for energy density is joule per meter cube. Okay, so next one they are asking obtain the energy per unit volume. We have already got. Hence arrive the relation between U and the magnitude of electric field. Okay, so I need to calculate the relation between the U and the magnitude of electric field. Okay, see here, so here the relation between magnitude of U and the magnitude of electric field is given by U is equal to half epsilon naught E square. Okay, so this is the relation between the U and the magnitude of electric field. Here I have U also and electric field also. Again I need to calculate electric field, but electric field, so there is no data they have given. Okay, so now again the concept I will use. So the relation between electric field and electric potential. Okay, the relation between electric field and electric potential is given by E is equal to minus dV by dx. Okay, so E is equal to minus, sorry, this one is minus dV divided by, so dx. So here, so I will take it as, so V divided by, in the place of x I will take it as d. Okay, again, so what is V value? So V value I need to calculate. So V value here is, so 400, again voltage value is 400. So divided by, so d value is, so 2.5 into 10 to the power of minus 3. Okay, so if you simplify, so you will get 1.6 into 10 to the power of 5 volt per meter. Okay, so it is volt per meter. For voltage is volt, and for the distance is meter, volt per meter. Okay, so next finally, so substitute here, so half into, what is epsilon naught value, 8.854 into 10 to the power of minus 12 into E square. What is E square? So 1.6 into 10 to the power of 5 whole square. Okay, so finally if you simplify all the terms, so you will get 0.1133, so joule per meter cube. Okay, so this is the required solution. Okay, see, I will explain once again. See, initially they are given area value. What is area value? 90 centimeter square, but this centi should be in meter square. Okay, that's why I will multiply it by, so 10 power minus 2. Okay, whole square. Okay, next distance value they have given, and voltage value given, and I need to calculate what is the electrostatic energy. Okay, electrostatic energy I need to calculate, and energy density, and the relation between the magnitude of U and V. So sorry, this one is U and V, the relation between the U and E I need to calculate. Okay, so here initially it is calculated by the formula energy U is equal to half CV square. See, they have not given. Again, see, formula I need to use, and again energy density is given by energy per volume. Again volume they have not given, so volume formula you need to simplify, that is volume is equal to length into breadth into height. Length into breadth can be written as area. Okay, so finally you need to arrive the relation between the U and magnitude of electric field. U is equal to half epsilon E square. Again E they have not given, so that's fine. So the relation between electric field and electric potential is given by the formula E is equal to minus dV by dx. Okay, so thank you.